Well, hi, good morning. Thank you so much for joining me in my shop here on June 16th. A beautiful day here. Not too hot, but my burgeoning astronomy career has fallen flat this summer because there's just too much smoke or cloud in the air every night. Nothing to see. But what can we see here with this radio? Okay, so yesterday I started sort of exploring the radio by putting a signal into the antenna and seeing how far it goes. Didn't go very far at all. Didn't get anywhere really. That I ended up looking at the coils that are under here and realized that I can't just look at them and sort out what's going on. I'm going to have to make a diagram. Making a diagram like that's not a lot of fun, so I didn't do it. So what am I going to do today? Today, I'm going to do the kind of the opposite. Instead of trying to stick a signal in at the start of the radio, I'm going to stick a signal in close to the end, close to the speaker, and then try to work my way back this way with signals and see if the radio works beyond whatever's happening in the front end. And what is happening in the front end, I don't know. I really don't know for sure. So now in the meantime, I have to thank one of you, Rory. Thank you very much. She sent me an email, asked me about the tube complement in here. I sent back a reply, and then you took that list of tubes and compared it to the original tubes and determined that in fact you could literally pull out the original tubes, plug these guys in, make some minor changes such as changing the input heater voltage from 2 volts to 6 rather. That's done with this transformer here. And because the original tubes were just directly heated cathodes, there's no separate cathode in them, it's just the heater. These tubes all come with a cathode that's attached to a pin that would potentially be going nowhere in this radio. And so that pin, that cathode pin, has to be connected to the chassis. In a when viewed simply. And maybe that's all it takes. And so that's perhaps what this person did, and perhaps this isn't the only radio that's had this done to it if it's that easy. Well, it's not that easy, is it really? At least I still can't imagine that it's that easy to do. But here it is in front of me. Now, because the original tubes may not have used all the tube socket pins, some of those unused terminals underneath the radio may have been used by the original radio manufacturer to make connections. And so this may have presented a problem because some of those same spare pins may have stopped being spare when this change was made. And so there would have to be a little bit of effort there to remove the original connections to whatever pin it is. And then they would have to be remade somehow, perhaps floating, or perhaps onto another spare pin if there was one available. And this would start a lot of wire tugging in this radio, which I've noticed an awful lot of wire tugging. The wires going to the coils, which I may as well tip this up. I'm gonna need it to be up anyway. The wires coming to these coils, especially this one, and there was another one, this one here, have been extended to reach the terminal that they're going to. Actually, you haven't noticed this before, but there's also a little green wire attached here. It looks like a Bell telephone type wire disappearing in behind this coil. We can't see where it's going. This coil also, and I'm sure you can't really see it, there's a piece of paper thrust down into it. For what reason? Why would somebody do that? I have to guess some kind of mechanical insulation keeping wires from touching or something of that sort going on inside this coil. Why was this done? And is it done correctly? That's the part that I have to make a diagram to sort this out, I think. But let's not do that, as I mentioned. What we can do here is we can start putting in some signals. I think the first thing I would want to do is put in an audio signal right where the radio develops an audio signal, and let my audio signal continue through the radio and out the speaker. Hear what it sounds like. Sounds good? Audio circuits, thumbs up. Sounds bad? Then even resolving these problems just gets you further down the road to another problem. And that's what I'm really interested in finding out. Is there more stuff in here that's wacko? So we will start with that first thing. Now, where do you inject a audio signal into a radio like this? Very often, right across the volume control. The volume control is here's the volume control. Here's the 3 terminals on the volume control. Let's say this is the volume control here. There we are. Very good. So you're putting the entire audio signal across the volume control. And then the slider in the middle is selecting how much of it you want to send on its way to the speaker. So if you pump in a signal here, why? Radio shouldn't really realize that it's an alternate signal. So especially if one side of the volume control goes right down to the chassis. So we'd like to see that. So this is the audio coming out. This is the grounded terminal. It's grounded solidly right to here. This is another terminal attached right to the chassis here. So that's the grounded terminal. This will be the input terminal here where the audio is coming in. So I just got to take my audio, feed it in there, and hear what we hear. Now what signal level? Not much. Wouldn't take much of a signal there to come out of the speaker quite loud. The volume control will still operate under this kind of test. So let's just keep going. Let's keep going. I don't know how long I'm going to work in here today because it is another nice day outside. And did I say yesterday I successfully mounted my 2-meter ham radio antenna up in its permanent location. So I'm pretty excited about that. Mind you, I don't have anybody to talk to except one buddy who patiently has been waiting for me to kind of get this sorted out. And so now, I'm not going to hook this up right away. I'm going to turn on the radio, get it operating here. And I'm going to be using this signal generator here. So we just want to turn this guy on and put that there. We don't want it sweeping. We want it fixed. And we want an audio signal. So we'll put in something like, let's say 4 kilohertz there. 4. That should be a pretty high tone. Let's come down. That's a little too high in my ears. 3 kilohertz tone. Still pretty high. Why don't you use the standard 1000? So out here will come some level that I can control with these buttons and with this control here. Okay, we're going to apply the power now. Here we go. Now if this meter's been catching your eye, this meter is plugged right into the extension cord. That's what this is, this gray. That was odd. This radio made this sound. Something like that. That cord is going straight to this meter. And this meter is not a 0 down here, it's 100 volts here and 140 volts there. So this kind of ranges in the area where you might operate a radio. So you can look at this and get an idea of the voltage here. Is that an oscillation starting up? So again, it has that sound to it, like the speaker's operating down a tunnel. Oh, it's not that. Now, we want to kind of silence the radio part of things, or do we even care? Maybe I don't even care. I'll hook up this signal generator without a capacitor might be not the best thing to do. I've turned it into a musical instrument now. we'll do the test down here, away from the oscillation. I believe. Take a fair size capacitor. Put this on the input side of things. That's what I'll say about that. Okay, we'll put the ground on the ground. Put it on the chassis here. Everything makes a difference. Now the output level is very low. Okay, the output impedance of the signal generator is only 50 ohms, so it probably just drowned out whatever was there before, which would be noise from the radio itself. Here we go. What do we hear? There it is. Turn this down. We'll up the input level. Well, that sounds just fantastic. Let's go down. Let's go down this way. So that's supposedly 70 hertz, but I don't believe that's 70. We wouldn't hear it. 60. So, oh, that's 1,000. I'm sorry, I'm reading this wrong. That's 1,000 hertz. 1,000, 900, 800, 700, 600, 400, 300, 200. A little bit of trouble hearing that. There it is. But it's just kind of a buzz. No problem. Okay, so this test shows that the audio, if we can get good audio to the volume control, it's going to come out of the speaker and sound lovely. Now we want to back up another step. We should back up to the input of the IF and feed in an IF signal and see what we hear. Notice there was no garble, nothing going on in the audio. So, okay. I can use the same signal generator. Just got to remember where to input it. I think I drove it in through the antenna before. That's not so good. Or did I stick it right into a grid cap? We should stick it into the grid cap of the mixer tube. That's where it really should go. Okay, let's do that. Turn this down. Okay, grid cap of the mixer tube. It's way on the other side here. Okay, let's do this. I don't like to do this with radios that are operating. I tip them like this. But I will do it with this one. Because let's say I'm halfway through doing this and the thing suddenly makes a huge squawk, I'm liable to jump and drop the radio. But it did not make a huge squawk. I guess it's still making some kind of... Yeah. This will be the one we want to go in. Turn it down, turn it down, turn it up, turn it down. Leaving it connected here. Easiest place to clip is right there. You can see that if you get a signal to this tube, it's pretty sensitive to it. Let's get a signal to that tube. Now we want to put out 455. I don't usually use this signal generator for this purpose, but let's do that. I don't know if you can read these numbers or not anyway. Wrong one. 455 right in this area. So this, there we are, 455, and pretty strong level. Lock it down like that to start with. Oops. Put the ground on. Once again, it's tricky to find something to clip to in this radio. Oh yeah, I remember. Once again, this will probably deaden the radio, but maybe the tone's going to come out. It didn't deaden it. Okay. Yep. There's no modulation in this. This is where this is not the best signal generator. Oh yeah, right on. So there's no tone because there's no modulation there. Well, that's not going to be any good, is it? Because I've got to hear the tone. You can already hear there's weird sounds in there. Let's advance this. That's it. So we're going to go here. So what I'm doing is I'm skipping this tube, skipping this transformer, and sending a signal into here. Ooh, nothing. How come nothing? The clip lead's gonna pop off. A frequency thing? Where? You need more signal. This is more sensitive here, or less sensitive as you go. More signal. There we are. The clicks are probably this thing jumping a little bit. So now there's a hum there. I doubt the hum is coming from here. The hum is inherent in the radio. The volume is about halfway. No, it's actually full. Full. Okay, so if we turn it to a more normal position, you don't hear much of anything. Well, this is kind of suggesting things are good beyond here, but I really need to use the other signal generator because this just isn't the right. This isn't the right. Okay, we're going to switch signal generators. While that guy's warming up, which only takes a minute, I'm going to go and slug back some coffee. Okay, switched over to the other signal generator now, and this one's putting out a tone at 400 hertz, 1000 hertz. Still feeding into the IF amplifier tube. That's what this should be called. This guy here. We're good to go here. Okay, dial this down to 455. Here we come. So now, I hear a warble in this. So this doesn't sound like a pure 1000 hertz tone to me. And I would guess, just as a guess, it has to do with the cathodes connected to the chassis in this radio. That's a guess. The chassis is carrying the current for all the tube heaters, I think. I have to look more closely at how it's done. Did they run a pair of wires to every tube, or one wire and one heater terminal is just grounded to the chassis? I have to look for that. So let's back this up. We'll go from this tube to this tube. See what happens here. Turn this down. Put that off. A little noisy. So I still hear the very same audio wobble. But there's another sound in here now. Kind of a higher pitched whiny sound. Could that be coming from the antenna? Yes, that's what it is. So we're trying to... Doesn't seem to want to oscillate, huh? Or is it oscillating everywhere? Maybe it's oscillating all the time now. I'm going to move this from here to the antenna input without changing the signal level. And absolutely nothing. So it proves once again that the major problem in this radio is getting the signal from the antenna to this first tube. And it has to do with those coils. So I'm right back right back to where I started. I have to make a diagram of the coil wiring and sort it out. So the other thing too is that if this is a converted radio, which I'm 99.9% sure of it now, that means the original circuit diagram that I found earlier that matched this number here is valid to a large degree. Maybe I gotta go take a look at that schematic again and just see what it shows about these coils. Well, that's a good idea. So I just want to thank Rory again for his email. I think I probably would have stumbled onto what he's revealed, the fact that you can swap all these tubes with minimal work. I was already on to the idea that there's no way somebody just figured all this out and figured out which tubes. It must have been some standard approach here, and I think the standard approach is you pull out the 1-volt tubes, or the actual 2-volt heater tubes, pop in the 6-volt tubes, change the input voltage for the heaters to 6 volts, and then tie the cathodes. Let's start with that. Tie the cathodes. So if you look at this tube, and I'm going to zoom in here a bit because we're going to be looking at these coils over here anyway. So just take this tube as an example. This is the first tube in the radio. There's the heater right there, and you see there's no cathode showing. Instead, what you get are the signal grids and suppressor and screen grids here. No cathode. But you also can see that this terminal is spare and this terminal is spare. That's probably the case all the way along. This one's spare here, spare here. Lots of spare terminals. So the radio manufacturer may have utilized these spare terminals to make connections. So for instance, this connection, which they've shown in the middle of nowhere here, could in fact be located on this terminal because it's going nowhere. But once you swap the tubes, one of these terminals is going to become a cathode terminal. So that would force some more changes to take place in the wiring at the sockets. But not so dramatic, and not just a guy winging it, got his tube manual out and picking which tube to try here or there. I don't think it was quite like that. And for all I know, the fellow who did this was the 5th one he'd done. I don't know for sure. Let's look at the antenna arrangement. So the ground just goes to the chassis. The antenna comes in, meets a switch right away. If you have it switched to broadcast, the antenna signal is fed through this primary and then to the chassis. So there's nothing to it. This is real simple stuff. Through the primary down to the chassis. On the primary side. Same thing on the shortwave. Now we look at the output. Let's just jump to the grid here. So here's the grid shown here. The grid comes down, there's another switch. So this grid is being switched. A variable capacitor here. This must be the one that's tucked. No. These two are the actual big air capacitor, the tuning capacitor. This one's for the oscillator. This one's for the antenna circuit, or in fact, this coil. This capacitor is resonating against this coil. And what's this here? Why is this here? Is that a trimmer? Well, perhaps this is a trimmer. Let's see, we're looking at the different... No, every capacitor symbol has this line with an arrow on it. So, C1, C1. C3, C3. Okay, don't quite follow that, but I'm pretty sure, because these are shown gang together, this, and they're shown with a different style of symbol, this has to be the tuning capacitor here. Okay, so we come out of the transformer. This guy's sitting there, who knows why. We come here, and we have this capacitor resonating with this coil. So very, very high impedance takes place when this is resonant. And the signal goes right to the grid. There's nothing here. There's nothing to this. This is as simple, really as simple as it gets, except for the switch here. So when I was doing the test, I was able to identify this point and hear the signal. I was able to identify this point and see that it's definitely grounded. I was able to shove a sensor or a coil up inside here. These coils are not side by side like this, they're end on end. So as I pushed it in, first it went past the secondary. And when I got towards as best I could tell, up towards the top of the secondary, getting close to the primary up here, seemed to show the maximum signal. So I couldn't really tell if it was coming from the primary or the secondary. My guess would be it was the primary. Coil. Now, secondary coil. So let's just trace all this out. So we know that this side goes to the grid, not much else. This other side, where is it going? It's going... Okay, the battery. Now we get to look at this battery situation. I don't think you know what? I think I forgot. Have I forgotten about this? I think I forgot about this. So what I had done was I had put a short in. But I thought this battery was sitting in a grid circuit somewhere. Is it really sitting in a grid circuit? The negative side is pushing this negative. I mean, that's what you want on a grid. So we follow it up this way. Sure enough, right to the grid cap. And this one we already know. Follow it back through the coil. It gets to the grid cap. So this is biasing these two tubes. Now these aren't the same tubes anymore. And the tube biasing could be dramatically different. I think we need to look into that. The fellow had put a 1.5 volt battery here, basically just replaced this with the original carbon button battery with a AAA. The interesting thing is, all things working normally, there is no current draw on this battery. Everywhere you go, we should just meet up with dead ends, like capacitor. Battery current can't go through the capacitor, can't go through the capacitor. Then we could do all this. We'd find out that this battery is just sitting in there. It's pretty much on the shelf, sitting there. No current draw, unless these capacitors are leaky. Then you're going to draw a current and you're going to drain this battery. You're also going to pull this voltage down, the bias. I'm really curious now about the bias and the wisdom of this battery being here. Often the way they bias these tubes is rather than force the grid negative, which is tricky to do, which is why they had to stick a battery in here. Where are you getting the negative voltage from? There's a couple tricks that can be played in the power supply to create a negative level in the radio that can be utilized, but that's not done here. So my phone is ringing. Okay, well, I think I'm back to having to really diagram out. Hey, it's 9:43. Diagram out the coils in the front of this radio. How it is the signal can't make it from here to here. There's almost nothing in between, just that transformer. Come on, will you please stop that? It's as bad as a cat. Well, so that's what I'm going to have to do. Now, the great thing is the schematic I think is going to be helpful. Thank you again, Rory, for setting me on that path. The problem has to lie right in the front end, the main problem. The secondary problem of the warbly sound and that, well, maybe it's related, but I kind of doubt it. So I'm back to having to plot these guys out and figure out what's going on. So I'm not going to do that on video because it's just too fiddly and I don't want to do it. I'm trying to avoid doing it. It's not working out though. That's great. I think I'm going to call it quits right here today, and maybe tomorrow I'll have that diagram done. Maybe. Thanks a lot for watching. See you on the next video.